All right, so some properties of ionic compounds that we are going to talk about right here. First one being that they have high melting points. Okay, so ionic compounds have very high melting points. All right, and I'm going to give you a reason why right here. Okay, so here's why they have high melting points. All right, think about this with me. Would you expect something that has a high melting point to have a strong bond or a weak bond? Strong. That's correct. Okay, so ionic bonds are the strongest bond. Okay, so when you have that negative and positive interaction that comes together to form an ionic bond, that results in an ionic bond, which is the strongest bond that we have. All right, so out of all the bonds that we're going to talk about, an ionic bond is the strongest. Stronger than covalent, stronger than metallic. It's the strongest of the bonds. All right, so they have high melting points. They have the strongest bond. They also are solids at room temperature. And that goes back to having a high melting point. Okay, something that has a very high melting point at room temperature is probably going to be a solid. So all of your ionic compounds are solids at room temperatures. And if you think about probably the most common ionic compound is sodium chloride table salt. All right, the melting point of sodium chloride is right around about 800 degrees Celsius. So like that's super, super high. Okay, like room temperature is roughly 20 to 25 degrees Celsius, so 800 degrees Celsius, way higher than that. Okay? So they are solids at room temperature because they have very high melting points. All right? And also, you can think of this. Solids have the most attraction. When we talked about physical states of matter, so you have solids, liquids, and gases, solids have the highest attraction to one another. So they are more solidified and more held together. So naturally, they're going to have higher melting points. Okay? All right. And last one here. They conduct electricity I didn't mean to write at there. Conduct electricity if melted or dissolved in water. Okay? So they conduct electricity if melted or dissolved in water. So if you take an ionic compound and you melt it or you dissolve it in water, it should conduct an electric current, allow an electric current to pass through it. Okay? Now, is it easy to melt an ionic compound? No, because remember, they have very high melting points. So it's not very common for an ionic compound to melt, but it is pretty common for it to be able to dissolve in water. All right? Most ionic compounds are going to be pretty soluble. So most of them, if you dissolve them in water, they will conduct an electric current pretty easily. All right? And I'm actually going to show you that here in a demonstration. Okay? So I'll let you get that copy down. Make sure that you have those different characteristics of an ionic compound. All right, for the people at home. Okay, this might be backwards on there. Maybe. There. Ionic compounds have high melting points. They are the strongest bond, solids at room temperature, and there you go. Okay? All right. Now, if you would like to get closer, you can come up here. Okay? Get a little closer. Nobody wants to get closer? All right. Just make sure that you're in a place where you can see. Okay? Matt, put your phone up there. Yeah, exactly. All right. So, we have a couple things that we're going to take a look at right here. All right. This is a conductivity tester that I have. Okay. So what it is a light bulb. It's got two probes on it. Okay. These are basically two electrodes. If these are connected, all right, an electric current can pass between them and light this light bulb. However, they are not connected. So it needs a way to be able to connect those two electrodes. Okay? Now, I do want you to understand, ionic compounds will conduct an electric current, not produce an electric current. I still have to plug it in. Does everybody understand that? Okay? So, what we're going to do, first off, I'm going to take just pure water. Now, this is water that's straight out of the tap. This morning, when we did this, we found that there were some ions that had to have been in the tap water because it actually lit the light bulb whenever we used this morning. And we weren't sure if it was because of the salt that was in there, but we washed it out, still put water in it, and it still lit it up. So we're going to see about that. All right, so it's plugged in. If we put this in here, all right, so you can see that it lights the light bulb just a little bit. Okay? So that's because there must be some ions that are floating around inside this water. Pure water really should not conduct an electric current, or at least very well. Okay? Now, I'm going to show you this. Okay? All right, this is water that I got from my house, and this water has been run through a purifier. So really, any ions or anything like that should be removed. All right, so when I put that in here, okay, so see, it doesn't light it at all. That's really what pure water should do. So obviously the water in Lebanon has some kind of ions floating through it, all right, whatever those may be. Okay? Now, I'm going to go ahead and take some salt. It's just pure table salt, okay? And I'm going to pour this in here. So we know that table salt is an ionic compound. All right? Now, what did we say about ionic compounds? There's two ways that they conduct an electric current. When they are, what, Connor? Melted or dissolved in water. All right, so this is neither melted nor dissolved in water. This is still the solid phase. And if I put those electrodes down in there, it doesn't light it up. Okay, that's because those ions are still locked in place. They're unable to be able to conduct an electric current. Now, I'm going to go ahead and put some of this water in here. Actually, I'll put some of this water in here just to make sure that you believe me that it's due to the salt and not due to the water. All right. So if I switch this around a little bit, dissolve that salt in there. Okay. I'm going to put this in here. Okay. And watch the light bulb. All right, so the light bulb goes on, then it goes off. On, off, okay? Whenever I put it in here, because what's happening is the ions that are in the salt are not locked in place anymore. Whenever they dissolve in water, those ions basically split apart, and it allows for them to be able to conduct an electric current. They allow the electrons to be transferred throughout that solution now. So it's being moved from one electrode, it's coming down one electrode and then flowing into the other, and it completes the circuit and allows the light bulb to be able to light. Does that make sense? Okay. So only when the salt is dissolved in water will this happen. All right. Now, I'm going to show you a couple other things here. Let's rinse this out. Okay, so baking soda is another ionic compound. Yeah. All right, now, again, if I put this down here in the solid, doesn't conduct an electric current. Okay. I'm just going to run tap water with this. You'll see how bright it lights. And really, the brightness of the light is determined by how well it conducts the current, because the brighter the light, the better of a conductor that it is. So baking soda. Oh, I got to plug it in. There we go. Okay. So the baking soda lights it up. Maybe not quite as bright as the sodium chloride. Baking soda is not quite as good of an ionic compound at dissolving as sodium chloride, but still pretty good. Okay. So there we go. All right. Now, one last thing that I will do. How many of you have ever had to take antacid tablets? You've had an upset stomach. Okay. So an antacid tablet does have some ionic compounds in it. So when it dissolves, those ions are actually free to move around. So I have some antacid tablets right here. I'm not going to use this whole thing, but just part of an antacid tablet. Take that, put some water in there with it. Okay, and the antacid tablet's starting to dissolve. All right, you see a lot of bubbles floating around. Now, the antacid tablet, if you look at the ingredients, one of the ingredients, it's got aspirin in it, okay? It's a pain reliever. And it also has citric acid in it, which is not a great ionic compound, but it is still an ionic compound as far as dissolving. And then it has baking soda in it, so sodium bicarbonate, which that's what baking soda is. So this also should light the light bulb. If we put it in there, again, we got to plug it in. My goodness, struggling today. And there you go. Okay. Little dimmer at the top, a little brighter at the bottom where the tablet was. Okay. But still, lights the light bulb because that is a very good conductor of electricity. All right. So that's what I want you to understand. Ionic compounds, they will conduct if melted or dissolved in water. Okay? Melted or dissolved in water. You're going to need to know that. Okay? Anybody have any questions? All right.